Good morning. I'm Dr. Balaji, Professor, Department of Pharmacology, School of Pharmaceutical Sciences, Wales Institute of Science, Technology and Advanced Studies, VISTAS. Have you ever had a headache, scrapped your knee and taken a painkiller? Yeah, you can take a small pill, and after a little while the pain starts to fade. But have you ever started to wonder how do scientists know the pill will work? How do they test a new medicine to prove it can actually relieve pain? Long before it ever reaches a pharmacist shelf. Okay, today we had a conclusion. Because today we are going to pull back the curtain on the very process. We are going to explore a classic scientific experiment that you just saw in the video, designed to answer that exact question. We will be looking at how scientists demonstrate the analgesics, which is just a scientific term for pain killing activity of a drug in mice using a method that is called Eddy's Hot Plate Test. Move to the explanation. I want to tell our journey today is broken down into three simple parts. I want to explain in a clear way in this experiment. That is, the three parts is why, how, what. The why. What is the core idea or principle behind the test? Second part is how. How was the experiment actually set up and performed? The third one. What were the results and what do they mean for us? So these three I want to tell you. The first part, the principle of the main test, why we are performing. So what is the main goal here? The objective is to see if a specific drug, which in our video was pentagocin, it can reduce the sensation of pain. So the key concept is something called the pain threshold. Imagine touching something warm, it gets warmer and also warmer. Then there is a point where it crosses from just hot to ouch. That is painful. That point is your pain threshold. So analgesic drugs, that is our painkillers. All of you know, it works by increasing the pain threshold. They don't magically fix the source of the pain, but they act on our brain and nervous system to make us tolerate more stimulus before we feel it as pain. Test this in a lab. Scientists need a safe and measurable way to create a mild temporary pain stimulus. And for that, they use the equipment you saw. The name is Eddy's Hot Plate. This is the first part. The second part, how the experimental procedure. Now let's talk about how the experiment was actually done. The equipment, as you saw, the Eddy's Hot Plate is a simple but clever device. I really like it. It has a metal surface that is heated to a very precise constant temperature. In this experiment, it was set to 55 degrees Celsius. It also has a timer and a clear glass filter to keep the mouse safely in one place on the heated surface. What is the setup? Experimental setup is to get reliable results. We cannot just give the drug to a mouse and see what happens. You need a baseline for comparison. That's why the scientists used two groups of mice. For example, group 1, it is a control group. This group is our baseline. They were given a vehicle, which is a harmless as well as neutral substance like saline water. It is enough. It contains no drug and also it shows us how a normal undrugged mouse reacts to the heat. Second group, that is test group. This is a group that received the positive control. For example, you give a drug swab testing. The example drug name is pentagocin. The procedure in the video was very clear and methodological. How? First example, there is injection. How to inject these drugs and the vehicle. Both groups were given their injection. The control group got the vehicle and the test group got pentagocin. The scientists then waited for 60 minutes. This is a crucial step to give the drug enough time to be absorbed by the body and start working. One by one, each mouse was placed on the 55 degrees Celsius hot plate and a timer was started. The scientists carefully watched for a reaction. The moment of the mouse lifted and licked, it's a paw or jump. That is paw licking or jumping response. Both you want to find out. This is the most clear signal of feeling discomfort. Final one, how to record. The second that reaction happened, the timer was stopped. This time is called the response time. For the ethical safety, and very importantly, it is a very important one, there was a cut-off time is 15 seconds. If any mouse didn't react within 15 seconds, it was removed anyway. This is a crucial ethical rule to make sure the animal is not harmed by the heat. Understand? The final part is what and the results and conclusion. So what did the timer show? This is where it get really interesting. For the control group, for example, no drug, the mice treated very quickly and also reacted very quickly. The response times were around 2, 3, and 4 seconds. Their average response time was just 2.8 seconds. Our results showing 2.8 seconds is the average response time for control group. This tells us that 55 degrees Celsius is uncomfortable and a normal mouse reacts almost immediately get the response. Now exactly see for the test group, there is pentagocin. The response time are dramatically different. There is 11 seconds, 12 seconds. Their average response time was 11.5 seconds. Think about that. 2.8 seconds versus 11.5 seconds. See, see the report. The mice that received the drug tolerated the exact same painful stimulus for about 4 times longer than the mice without the drug. Understand? Okay. So what's our conclusion? The experiment clearly demonstrates that pentagocin significantly increased the pain threshold of the mice, and also this proves that pentagocin has a powerful analgesic effect. And this brings us back to our first question. This is simple, elegant experiment is a foundational step in pharmacology. It's how scientists get the first clear, measurable proof that a new substance has the potential to be developed into a medicine that can one day help manage pain in all of us. Thank you for listening. Thank you for understanding. In case I have any doubts, please ask me. Thank you.